Okay, here we go. Another Codecraft. Yay.
Woo!
Okay. Michael, are you happy?
I'm always happy for Codecraft.
Yeah, that's good. We do it for Michael and maybe ourselves.
Sometimes.
You know, people can see my screen in the video. Should I like put cat memes up here just to like distract people watching?
I can see both of your screens, both you and Thomas's.
You can see if Thomas is goofing off.
That's right. You will see.
I can also see that Thomas, why aren't you in grid mode? Why are you in the super zoomed in mode?
So I can see your face. So I can see your beard. It's hard to see your beard from the top thing.
Oh, I mean, like it doesn't fill the whole screen with the grid.
Oh, no, actually I like talker mode. That's my preference.
Because you like talking.
Well, it doesn't show me I'm talking. I'm very disappointed. I got to stare at Tyler. Anyway.
Tyler and HD.
So
They're in HD.
this week we're looking at two more design patterns, Facade and Flyweight. And let's talk about Facade.
It's all a facade.
All right, let's do that.
So,
Yeah, I mean, I've done it before. I didn't know the official term for it, but it's I don't know, it's just that's what I did with the video recorder. Hey, we've got this complicated system or this other system, and one thing that I didn't see them emphasize as much in on Refactoring Guru that I think is a big part of it is just hey, you want to replace the system at some point, then that's also a benefit of it. Is it's just hey, we want a simple interface and easy to replace. So it's definitely something. I mean, maybe I'm getting a bit esoteric, but I feel like that's what all code is anyway. Is it's trying to create a simpler way to do something more complicated.
yeah, like that's what a method is, right? The method is like joining together a bunch of calls that you're like, I don't want to look at this later.
I could use a bunch of go-tos, but this is easier.
If that's what goes through your mind, I'm very concerned.
I guess my point is just that, like, with code, the idea is you're just simplifying the problem, and you're always trying to make it so that I can do more with less work. And so I sort of feel like all programming is following that concept. Like if I'm writing code, I'm trying to make my life easier, not harder.
Yeah. Maybe a cooking analogy works that you have all these ingredients out there, or whatever, and your method is simply reaching out and grabbing these different ingredients from different areas of your kitchen, of your pantry, or whatever, and then your method is mixing it all together, and then you got the thing that you need. So yeah, in that sense, the Facade is all programming.
The Facade is like a food 3D printer where you just press a button and it prints out a pizza for you. Those exist.
Except the analogy only in 0G.
0G, right?
It's a 0G 3D printer printing food from one button.
Okay.
Yeah.
Zero gravity, or is there something else?
Yes, zero gravity.
They have that in not zero gravity too.
Okay.
They have that in greater than zero gravity.
So, do we have good examples of using Facade? Like
Video recorder.
having it already, and you didn't even read the article first, probably, right? You did it, then read the article. Hey, this is how you do a video recorder.
Yeah, I guess that's just something that I mean, I've done that in multiple cases where it's just like this API is annoying to use. Of course, I want to have something that's in the middle of making it easier. Like if I'm using FFmpeg, I could always call FFmpeg calls, or I could make something that makes that a little bit easier.
We talked last time about rewriting and how do you know when to rewrite, and we talked about how difficult it is to understand code, and I've been having a terrible time trying to understand the town drawing code and what the heck is going on, right? So how do you capture that knowledge, right? Like, I'm going through the town code, you're going through this recording system. It's like, oh, you have to do this, then you have to do this, then this connects here and whatever. Like, how do you record that? And the typical easy answer is comments. You put in code comments and whatever. But writing a Facade is a way of capturing that knowledge, right? That it's like, you need to do this, and then this, and then this. And if you create a Facade that makes it really clean and simple, and then all that complex knowledge that you spend all that time trying to figure out how to use the system, you can put it in there. And then I liked how later they said, And you have facades on facades, and that's true architecture, right? Is that you're like, hey, this is the layer that you're going to talk to, and it can be all squirrely and whatever underneath there, and we don't care. This is the layer that you talk to, and then there can be another layer that you talk to for other things. And so, at the end of the day, when it comes to doing something, it's like, hey, I only have to talk to these 6 facades. I don't really care how the rest of the game is done. That sounds nice.
Is that kind of like when in C you you know, you print something or something like that, it's figuring out for you whereabouts that's done on the computer. You don't have to figure that out. Like that's being handled by something else. Is that a facade, or am I getting a little confused there?
In a broad sense, yes.
Yeah, I guess so. I mean,
That's in Josh's sense of anything that you're doing to make stuff easier is a facade. So if we're going with that definition, then absolutely.
Like, is encapsulation a facade? Like, by that definition as well, like all encapsulated.
Nobody gets that joke. Yeah, but
back to Tyler, yes. Yeah, sort of, yeah.
I would say
Yeah, so-
no, because part of the definition of the facade was that you still have access to the subsystem directly if you want to do more specific stuff. So it's not really encapsulated per se. It's just there's something standing in front of it that you can talk to instead of the subsystem. Whereas if it's encapsulated, you'd talk through that like only, right?
I thought that the facade, so I mean, something that you just said, and maybe I misunderstood, but is that it includes it sounded like you were saying that the facade includes a public reference to the subsystem, and I didn't see that as a requirement within it at all. I could see.
No, not through the facade, just that you can access it directly. Like you can access the subsystems without using the facade.
Oh, yeah.
So therefore it's not encapsulated by the facade.
Yeah, I think Tyler was just asking like, oh, is encapsulation kind of like facade? And the answer is yes, kind of.
Yes.
It's solving a similar problem.
Yeah.
Whether the approach is the same or not doesn't matter as much.
Yeah, I mean, I guess to some degree, my noise utility class is like a facade because it's doing a lot of like math and stuff using like Unity mathematics for like generating noise and doing calculations on noise and stuff like that. But at the same time, as Zach pointed out, then you can just access those mathematics functions and do it all yourself as needed as well. It's just that there are a bunch of like essentially helper classes that simplify it all. So you just like call the method and you're good to go. And it does it all for you, kind of all the complication stuff.
I guess for me, the idea of a facade is you're really sacrificing complexity for simplicity. You're trying to say, hey, what's an easy way to work with this very complicated thing? And you might lose some of the core functionality, you might lose the ability to set the default option for this random setting. But generally, that's not a thing we care about. And if you really do, you work with it directly and you figure it all out.
Yeah. Anybody else have good examples of using facade?
It seems
It's
pretty
not-
straightforward.
Not an example, but you were talking about bird's eye view as like this thing that it's just a mess and it's hard to work with. And maybe it wants to work for bird's eye view, but in some ways, if we could just add a facade to it, we're like, hey, here's how we work with it, then maybe we don't care how messy it is internally.
Yeah.
Like in some ways, that's sort of how I treat serialization. Like I assume Josh made a very great serialization system, and from what I've looked at, it's not that bad. But if it was terrible, I don't really care because I only need like save and load,
Yeah.
and that's it. Because there's not that much I have to interface with, and so in some sense, it doesn't matter if, well, actually in some sense, our serialization is a facade or a nuisance soft. But yeah.
The one pet peeve that I've had or seen with facades is when people are just like, I'm not going to learn the system. I'm just going to make another facade on top of it when they have full code access, and then you just get 5 layers that add nothing or simplify nothing. That's like the dark side that I've seen happen sometimes. It's just like, oh, we're going to make something that it just calls the lower method, and then you get like 5 layers, and it doesn't do anything. And again, this is assuming that you have full code access to where you can just chop off 4 layers and you have the layer that you actually care about.
That's not a true facade. Like they're just, I don't know why they're doing layers. Like they're not doing a facade at that point.
it seemed like that was the intention, was that they thought this simplifies it, and it doesn't. I feel like I've seen that a lot in web code where you have packages on packages on packages. Where it's kind of like, hey, this simplifies the system, but then maybe the functionality even gets added higher up in layers or something like that that was down below. It just gets weird.
So I've been doing a lot of refactoring over the last week, and I think a facade is a good example of a refactor, right? If you're refactoring, getting it down to a few simple calls, I think is the goal or the holy grail of a refactor, and I've almost reached that. So I went from, I think there were 12 different ways of getting a sprite image to show on that location screen, to now you just say get sprite on a location, and a location could be a building, and a location, yeah, it could be like a farm field or anything, and so when it wants to display the town, it also wants to draw a background of like what's behind the town, and it just goes, hey neighbor, get sprite, and then to the side, hey neighbor, get side sprite, and then that's it. And then you just see like these 4 calls, like get the top, get the side, get the other side, get the main, and then it goes into this kind of exploded out thing where it has to loop through all the buildings and show them. But all this code was sitting inside of what we call bird's eye view class, which was figuring out like, what are you, where does your graphics come from? Because if you're a small building, you come from this folder, and if you're a large building, you come from that folder, and whatever. It's like all this stuff, and just trying to figure out what are you. Oh, then this is the particular sprite that we should have for you, such. And so now it's all down to just get sprite. So yeah, it was nice to read about Façade. I'm like, oh yeah, that's what I'm doing here. Another one is game. So we have this one class which accesses most of the game. So for instance, if you're going to earn some money and you earn 100 gold, well, where do we store that in the player inventory, and how do we show something on the screen that you actually have that 100 gold, and what's the sound effect that we play, and whatever, like all that stuff's hidden away because we just go game.gold, get gold, or whatever happens.
We actually just changed that because there were issues with which inventory goes to the player owns and stuff like that. So we actually just removed that. You're welcome.
Yeah, so that's terrible. So the concept was, I don't care how it's implemented for getting gold. What I care about is I am doing something, the UI is doing something, and it results in the player getting some gold, and I call game.getGold, and bam, there you go. Same thing with taking damage. The player just took some damage. I don't care how it's implemented, the sound effects that fire and the screen overlay or whatever. Can you imagine every point in the game where the player takes damage, you had to go and do that, right? So the game is kind of being that facade. And then ultimately UI is a facade, right? So you have a UI layer, and what does it do? It hides away all of this logic and data and whatever, so that you can call the UI layer and say, hey, I want to do this. I click that. And then it goes, figures out all of the complex stuff. So that's where it starts to become software architecture.
So one of the big problems that I see when you're talking about using it in that way, though, is that if you want to swap out what you're referencing, and so one of the things that I've seen a lot is where we have a method that directly calls the player, but you generally want to slot another character in there potentially. So hey, take damage. Well, we don't really want this to be take damage. We want this to be on the character. And so if you end up calling game.take damage, and that's what you're using throughout the code base, suddenly you can't throw a character in there and have it work with them or things like that. So the one thing that I'm seeing with that in that case, and I guess this is kind of the case with with what is it called again? With the facade in general, is that if you would want to switch out the system or what you're calling, then that just makes it a bit messier, because if the facade is blocking you from swapping out an important piece, it's just hindering you rather than helping you. Like if you want to be able to pass a parameter instead, essentially, like we want to be able to pass this character to take damage, or we want to run take damage on this character. Because I saw a lot of places, and this is perhaps a different issue, but where rather than calling like player take damage or character passing through take damage, we would just be like, okay, game take damage, or which I don't think we have anymore, but game do this thing, and then suddenly it doesn't work for any characters. And so then it's like, okay, well, we got to refactor this anyway, and it's not as flexible and stuff like that. So that's
Essentially what happens is you lose out on polymorphism.
yeah.
So like if you're trying to say, hey, we want to be able to do this thing on both the character and on the player, but the player is a little bit different, you can do that via polymorphism. And what you have to work then with is you have to work with that object. You have to know, hey, I'm working with a player, I'm working with a character. And if you're abstracting out away with a facade, you're going through a game. You're saying, hey, we're gonna do this, and it's always with the player now. Like you're fixed to that because you can't change out the things behind the facade without having to reach through the facade, and then you're no longer using the facade. So I know Josh and I have not been a huge fan of some of the stuff on game that's sort of
Yeah.
abstracting out, like earn or take damage, because we're trying to access that in other ways. And
Yeah.
also we're just sometimes confused because we're looking for it, and then we see character calling player, calling game, calling player, calling character, and it's like this weird loop, and it just gets sort of messy. But I can totally see it with UI. I feel like UI is a great example where I just want a simple interface to work with a complex system. And I don't really care what it does or how it gets there. I just know I want it to print this thing, and it will print it eventually.
I was trying to use easy examples and you don't like either of them, but the fact remains that that layers of abstraction in architecture are facades, right? Because you're hiding away the complexity of the whole system. You're not preventing someone from getting it because that's adapter or bridge that is like getting in the way of it, that you can't actually get to it, but facade is making it easier in order to do that. So
We're just raising that because you're referencing examples that we've explicitly been removing because we didn't like it.
And because it was breaking the code in different ways, or it would be called, and then it's like, this isn't what I expected, and it seemed like that was happening a lot in the code base, is that people were calling the facades at what they actually wanted.
Yeah, I mean, so if we're wrong, if we're like, oh no, it really should be done some other way, then we need to know that.
no, I don't really care about those specific methods. I was just using them as examples. Like, hey, every time you go to earn money, there's like 6 things that have to happen. You want the client to remember those things? Like, no way.
I think a great example of that recently would actually be Travel 2.
Yeah.
Game.travel 2, and that's been there before, recent refactor on it, but hey, like, and maybe it should still be like player Travel 2 or something like that, but it's just taking the player and just going to this location rather than trying to like go through a lot of different things. Some of that is because there's just a lot of different calls that happen there, and so having the consolidated place. Yeah, I could see arguments for actually putting that on player and things like that, but it ends up still consolidating the logic.
Not player, character.
Yeah, well, sorry, I mean putting it on character and then having it player inherited and override a bunch of stuff and all that.
I mean, Thomas, I'm with you on the fact that we don't want clients necessarily now, but a lot of the stuff like in, so like the travel to, like it's not the client who's responsible for calling, hey, move a character and play the audio and do these things. I feel like that responsibility ends up elsewhere. Like it's not, you call a bunch of methods to do this, but you call the thing that says travel to on the character, and then that can delegate out responsibility as necessary. Because just like bird's eye view, like it's the character that knows what audio is it playing. You don't want to have a audio manager where you pass through the player and you're like, what audio do I play for this player? Anyway, I'm okay not beating that dead horse.
Yeah, so facades are for simplifying complex systems. And you know, he has in his real world analogy, right? He does a little picture of his, hey, you want to place an order? You got warehouse, payment process, suppliers, taxes, delivery. There's like so much stuff. So the travel to is an example of that. It's like, I don't care. Just do the thing, right? And so you don't usually, like when you're writing a method, it's because there's something that isn't happening. So I have to write a method to do something that's completely new. But a facade can simply be wrapping up and simplifying things are already there. It doesn't have to do something new. It's a view into the system. That's what I'm trying to get across, right? So if you start thinking in terms of layers and views and architecture, that's where the facades really help you. So it doesn't have to add anything to it. That's a method or a bridge or something else. So that's where I was going with earlier, that you can take that hard-won knowledge and code it into a facade rather than just relying on code comments both for yourself and the next guy. Anyway, it's good for UI.
Yeah, definitely don't want to be going through each of the nested elements and trying to figure out which one's for gold and stuff like that. It's much easier to just be like HUD controller, update gold or whatever. I mean, ideally there's a centralized point for that, but still.
It's funny you say about the UI, because I'm realizing that the design patterns book, most of it was about how do you do UI in different contexts.
Yeah.
And I don't care. I don't care. Just give me the UI.
I think it's because most business software, I guess I don't, thinking about the kind of software they're talking about, I guess that it was primarily focused on the UI. I don't know. I guess that I feel like most software, I don't know, Thomas, what your thoughts are on this, but most software is very much the UI and it's just everything is changed from the UI, whereas with games, there's so much where the player's input has nothing to do with it. And the player's input matters, but so much of it is everything that is besides what the player's doing.
Oh, yes, that is entirely true and different, right? So the concept of the game loop. So in business software, and web and business software are similar, but when you're working on the web, you already have this, there's presuppositions and limitations and constraints that have already been thrust upon you that you may not even realize. Because when you go and you start working in Windows Forms or even something even broader and more generic, when you can draw your own window any size you want and you control the color of every pixel on that thing and you writing click handlers for every pixel on that thing, like when you're at that level, it starts to really matter how your UI is written, right? As a layer, it really matters. Like in the web, you have a browser and there's like certain events coming through. You don't like have a lot of choices. And in business software, we're always waiting on events. You're just listening for events, and those are click handlers of some kind. Like you're always waiting on the user to do something. A turn-based game, I guess, like ours, is somewhat close to that. But then when you go to something like Assassin's Creed or Orcs Must Die 3, which is what I'm playing right now, you have the game loop, and if I don't do anything, there's still tons of stuff going on that it's processing and having to do. And so there is no equivalent of that in business software, of this game loop that's just changing the state of the thing as the user is watching. Usually it's the sign of good business software that the state doesn't change when the user doesn't do anything. I mean, there might be like, a stock ticker or something you have to go and refresh or something to show you like these state changes or whatever. But yeah, usually everything's frozen until the user does something. So it's quite different.
Is most business software front end? I always assumed there was quite a bit of back end as well, where you're just computing lots of stuff, or you're simulating a forest fire, or like there's applications outside of just like querying a database or a website or something.
So there are like that server side, let's say console command line kind of stuff that I've written services or whatever, and they like listen for events, or they it just the day rolled over, it's hit midnight or whatever, and now you have to go and generate. I wrote a service that had to print out order sheets and route lists for 150 drivers so that they were all done by the time they came in at 5 a.m. So I'd have to figure out all the routes, make up all the things, and send it off to the printers and know what my print queues were and whatever. But it's an event. So whether it's a person clicking on the screen event, or it's some timer like the day rolled over, the system is sitting around and waiting for an event to fire. But games are not like that, generally speaking, right? They have some kind of game loop that's just animating the screen. Like even if it's turn-based thing, we just recently put in some animated waves or smoke coming out of a volcano or whatever. Like that is very different from the business software. Any other thoughts on facade? Okay, flyweight. How many people have written a particle system and used flyweight?
I don't think if I have that.
Particle system?
Yeah,
What are we in the
I
early
mean,
2000s or something?
Flyweight's not necessarily only for particle systems,
I didn't say it
but it's
was.
very helpful for that. I could see flyweight being used for our locations with like tiles potentially. Like
Yeah.
where we don't store the actual tile on the location, like the art asset. We store a reference to it and then we kind of either clone it or do whatever we know what the tile should be. Or the tiles should be.
I was thinking, Tyler, isn't that what you're doing for environment types?
Yep.
Like,
That's exactly what I would do for environments.
that's what I
And
was thinking. There's
Yeah, for the map.
cache of that, and then you just reference the
Yep.
cache rather than storing the values everywhere.
yeah, I cache a reference to it. Yeah, that was all planned because when I made that, I was like, if I just store all this information and copy it for every location, like the map gets big. This is just gonna balloon into a lot of data that just doesn't necessarily need to, because it's all static information. Like, what is a desert? Well, it can be kind of predefined. It's not necessarily changing. So
Did anybody read the design patterns book on this, or is everybody using the website now?
It's using the website.
just the website.
I read it, but it was like a month ago now.
Oh, okay. I'm curious, do you remember what example they used? Because there's no way they used a particle system as their example.
I think they were using typing, so like letter glyphs, and reusing those.
Okay,
I could see that.
Trees are a common example.
Yeah, I use trees here.
yeah.
Like,
Yeah,
is that gonna be like Unix patterns? Probably like they reference the pattern and then there's just like a lookup table, probably for like typing key glyphs.
I think it was like they had, I can't remember. They definitely were using like Unix key codes somehow, and then was storing part of the letter data in a flyweight, and then I think the external data was like positioning and display data and that kind of thing.
Yeah.
so again, more UI, where you actually have to show all the characters the person's typing out, right? Like, how do you do this?
And I mean, Unity is doing the same thing with like our fonts.
Yeah,
So I'm scrolling through here and yeah, it's talking about like Times New Roman and whatever. So you're like storing these huge asset files and you don't want to carry around for every single character. You just, swap out and you're like, oh, what's the ASCII for that? Cool. ASCII plus location, and then you go, you're just.
Yeah, something that they don't really talk about here, or I don't think that they did, which surprised me, is another cool thing with the flyweight is if you want to change the flyweight value, like that's, or it's really easy to change, sorry, not the flyweight, it's really easy to change the reference values if you're like, I want all the particles to be red now. Okay, you can change that or stuff like that.
Yeah. For
I
the,
could be wrong, but I don't think that that's more difficult with if you didn't use a flyweight pattern, like because you're just defining it in the class. It's just that with the flyweight, you don't have lots of duplicated data. I think that's the only thing that the flyweight avoids.
Sure, sorry, I was thinking more so at runtime.
yeah, so Josh is saying like you have a million instances. And if you wanted to go and change the color from blue to red, without the flyweight pattern, you have to go through all million of them and change it, which is not necessarily hard, but is intensive, as opposed to, hey, if they all happen to be referencing in one instance, you change the one instance and now they're suddenly all showing in the new color.
Yeah, that's true. I guess that does highlight the downside as well, though, is that you better make sure that you want all your particles to be the same color, which it makes sense for bullets, but maybe it doesn't for other things. I don't know.
Yeah, they can obviously, like fonts, you can pull from several stencils, basically. I think that's actually a term they use in particles, is stencils. So you can have as many stencils as you like, and then if you change something on the stencil, then all the instances change. Kind of like prefab.
Yeah. I think though, like all it's doing though is trading RAM for CPU time, right? Like Because if you change it from like red to blue, you still have to update that on all of them, like all the particles you have. So your CPU still has to process it, or something has to process it, rather than referencing it. So your RAM is much lower, but you might just have like way more CPU clock cycles being used to update it amongst all of your million particles.
I would say it partly depends on how it's called. So like if you have a particle system that at the top level is having to call draw on all the particles anyway and run through them,
Yeah,
then you're passing a parameter through. And so while it could be increasing the CPU usage, you already have to make those calls anyway. So it's not
there would be no
necess-
increase with that. If you're drawing all your particles every frame, the stencil changed from blue to red, there's no extra CPU on that.
I guess so.
Oh, but if it's I mean, it'd be negligible if you were reading it or passing it through the method versus calling it locally, and maybe that wouldn't actually, like, if there is a change, it's negligible. I don't even know if there would really be a change, but there'd be a huge change in RAM usage because they only have one of the values. I might be thinking of something different than what you mean, Thomas, because I guess what I was meaning is passing through an additional, if you were just passing in the position of a particle versus passing through the position and the color. So if you're just passing through the position and the color lived on the particle, would that take up more CPU or take up less CPU versus passing it through? I assume that would be negligible. Passing through more parameters, I assume, is very negligible as far as processing power.
Yeah, it's up to you as to which things can vary, right? So if the color is going to vary, then you can have, you know, an individual color for every single instance. If the color is not going to vary, it's like, no, these are the 16, period. I don't care about gradation between red and blue. Like a lot of time in particles, you're gradiating across them. So every particle does have to remember its color. But if you're like, I don't care about that, it's either red or it's blue, then you do that on the stencil level. Off you go.
And if something is gonna vary, you don't want that in your flyweight. Or you want multiple different flyweights that you're carrying around.
Or you could also have like one thing that I could see is if you have a shared lifetime in general, but then you just want to alter the lifetime, you could. That's not a great example, but if you stored something that was basically a difference on the flyweight instead. So as an example, maybe you have a color that's shifting, but you don't want to store the current color. You could store like a point in time across the color gradation and just have that value be what's stored, but the color is still off of it.
Flyweight is black and white, hard and fast rule. Where does the data reside? Does it reside on the stencil or does it reside on the instance? Right. And you're talking like, well, what if I want to override the value? Then it resides on the instance, period. It does not reside on the stencil. It only resides on the instance. It's not on the stencil and also on the instance with an override.
No, what Josh is saying though there is like you're splitting it. So instead of saying, hey, you have data on the flywheel and on the instance, you can have the base on the flywheel and you can have an addition on it. So you're essentially saying instead of one piece of data, you have two. But if the only value on that is if you really do need that sort of flexibility, but generally that would only be like in the case that you're doing something like a git difference where like you just have a really small change in a massive amount of stuff. And so you're trying to say, hey, here's a large thing that's the same for everybody, but everyone has a slight variation of it. But you can store variation separately. So you're maintaining your delta.
Which, depending on the context, might do absolutely nothing. So it depends, but yeah, sorry, that's what I meant, not like overriding the value, but some sort of adder to the value, which would only really be helpful if the addition is significantly smaller than the value that you would have to be storing otherwise.
I
And
think,
the flip side of it, Josh, is also that if the thing that you're storing everywhere is big, like if it's not big, you don't really need it in a flyweight. Like flyweight is an optimization.
Yeah, I was thinking like a lot of particle systems, they'll do like a start like color and an end color, and that's probably to save memory because I imagine colors are pretty big, being like a collection of floats or something like that. Like they take up a lot of memory. So in a lot of particle systems that I've seen, you can set a start and end color, which I assume is like in the flyweight part, not in the individual instance. And then based on lifetime, which will just be some float, individual float, they transition between the two colors. And so I
Yeah.
think that that is probably a better example than having a base lifetime and then adding a value onto it.
Yeah, I
think
mean,
that kind of gets away from Flyweight.
I think the strength of it mostly comes though from the fact that you might want 1,000,000 plus of this data being copied across places, right? If you just have like a single like game instance with a large data set of, I don't know, locations, and or not even large, you just have like a, you know, a picture on there. That's the only reference to that picture ever. Then what's the point of putting it on a Flyweight? There's no strength to it. You're still having the same data somewhere. The strength of it comes when you have like 1,000,000 particles where it's like they're storing like 5 colors on them, or they're storing a color, which when multiplied out to 1,000,000 particles is just a large amount of RAM, or a large amount of stuff that needs to be copied over. So that's mostly where that strength comes from. And that, I think that's why particles are a very good example of flyweights being needed, or stencils.
I don't know if this helps anybody, but the flyweight pattern is how GPUs work with textures and such, right? So you take your texture, jam it into there, and then it's just bam, 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 bam. And then that's why the performance is so much better when you reuse textures rather than having to constantly keep switching around to different textures.
I was thinking, I'm not sure if it doesn't seem like the right application. I'm thinking a bit of your sprite caching system and trying to figure out if that's not really maybe a good comparison, because
it's just a cache.
Because
but what would be other good cases for it in Archmage?
So, I was gonna say, I don't know where we got to with how many like tiles our map is, but if we get to like say 300 by 300 tiles, then the suggestion of location, like the image being in a flyweight, kind of makes sense, especially at the base layer. I definitely see value in that.
I mean, let's just think about it this way: 100 by 100 map has 10,000 tiles. If you have like a 10 megabyte like image, or 10 megabytes of image per tile, that's already 100,000 megabytes of data that you're storing just for that map. If you're copying it across everything, which is that a gig, or 10? Is that 10 gigs? That's
that would be
10 gigs, right?
10 gigs, yeah. I hope we don't have a 10 megabyte image.
100, is that 100 gigs?
No, it's 0.1 gig.
Wait,
A gig is 1,000,000 megabytes.
That's right.
It's not 10 megabytes. It's not.
No, it's 1,000. It's 1,000 megabytes.
Yeah, I was like, I thought it was 1,000.
It's 1,000 megabytes. So it's
megabytes.
Yeah.
So yeah, we already implemented this on the map. That's the only way you get performance of the map. Otherwise, the map is stupid. Anywhere else in the game?
So it's not like a memory intensive thing, but so like for like spells or anything that we want design data for, in some ways, like the collection of data that all instances of that thing have, is sort of like a flyweight, because we're like, hey, we just need these pieces. And if we keep that as a separate method, then we can refer to that data on its own, as opposed to all the serialized data that we have to store and change for every instance of an object. So.
Michael's jumping ahead because he's also read game design patterns.
Am I? It's been a while since I read that. Then.
Yeah, we'll get to that in a second. But in the game right now, so I wrote down the map. Is there any other things? Obviously, we're not making a particle system because Unity gives us one, so that doesn't count.
One of the things that comes to mind is just anywhere where you have repetitive strings. So if you're storing like the same reference to an image, for example, on everything, if you can instead have it, whether that is passing through or whether it is calling something shared, then that's something that can be valuable. So if, for example, now I'm not sure if that Flyweight doesn't seem like the right approach for that. In my mind, you would have a few different possibilities for that. Like maybe you have a property that references some shared data class that then you're pulling in the value from, but rather than storing thousands of strings for all these enemies, it's just, just point to this thing and get it to me.
Well, I sort of did this in it's maybe a little bit more caching than it is flyweight, but in the case of the town buildings, each one of those buildings could be 50 different sprites. So I actually thought earlier today that when you create the location, that I have a list of the 50 possible sprites. I actually thought that was per instance of every single building. I was like, oh, that's super dumb. I got to go make sure I change that. And it turned out I had actually done it correctly. So I was relieved. In that particular case, it was just easy to make it static, right? So this is static on the building class, and boom, it's got one copy of all 50, and all the instances reference that 150. Is it exactly Flyweight? No, it's in the same kind of idea of what data is intrinsic and extrinsic for my uses. Whenever you run into this kind of situation, like it talks in the site about you want to make sure these things are immutable, right? Because you can't have people going and monkeying with this data. So that's where struct helps you, because that forces it to be immutable. There is other ways. You just make everything private and then they can't get at it. That's the other way. But I just, I like to bring up struct every once in a while. And this week is the week that we talk about struct, and then I won't talk about it until July of 2023.
We'll do that. I don't care.
Yeah.
In my game jam project I'm playing around with, I was doing some stuff with scriptable objects. And so scriptable objects sort of all under the same sort of thing where you have like, here's your set data for it, and then here's your other stuff. And earlier this week, I made the dumb mistake of storing mutable data on my scriptable object. And then I'm wondering, well, my data is changing everywhere. There's a very good reason for making it immutable.
So another example in Archmage is the tower square. So when you're building a tower, there's like every single square on there. Do we want to store like lots of data about every single square? No, we don't. We just want to know which sprite did you slam down there. We need to know the XY, we need to know the sprite, and that's it. That's really all we need to know. And that's the thing. I don't even remember how many squares by how many squares, but that's where the 10,000 squares comes in. And then we're all just referencing basically a palette or something from that. So yeah, Michael jumped ahead of my two fancy examples. So one was scriptable objects is doing Flyweight just in a different kind of way, which he already described. And then the reason I was referencing the game design patterns is because he uses it, it's halfway through the book where he talks about monsters and how you can do your monsters using this kind of Flyweight pattern where it's like, hey, you don't have to store all these values of say max HP or attack damage or something like that. You don't have to store those things for every single instance of your ogre. You just have the one Flyweight which holds the intrinsic data, and then your instances of each one will have just the little parts that change. So current HP is something that changes. And so he goes through that. So it's an interesting way of using Flyweight. It's very much the scriptable objects approach, but in a pure code way.
We are going to be doing that with design stuff, I'm aware of.
Yeah, we'll have to figure out how to make that work, but this is definitely something that we want that to tie into, because right now, yeah, if two mages have a spell, all the data that is the same is shared across them, which not a big deal. But that's how design data is handled across the game right now.
Technically true. The spells have their own, spells in the stuff for combat has its own design data and its own separate class, which is shared between instances. Now, the downside at the moment, most of the time we just have one instance, but the main split is between data that we have stored on file and data that we've stored in the save file.
Yeah.
You were saying something, Tyler?
I was gonna say that I just checked to see how the data was stored for the map tiles. It's almost already in like a Flyweight situation where like the tile itself isn't actually all that big. It just stores a reference to the image. So where the image is like on average about 100 kilobytes, but the tile is like less than 1 kilobyte. So in that sense, it's already doing that. That'd be generally safe actually to should just reference the tile because it's not going to necessarily have the image.
Something else was in the Gang of Four book was talking about how like when you're using flyweights, oftentimes the work gets done on the flyweight, not on the extrinsic part. And when Thomas was talking about structs, that kind of reminded me of that, because if you're using structs, then it's a value type. And so if you're passing it out of the flyweight, then you're going to be passing by value by default, which means that then you're not actually saving any memory at all, because you're just making a bunch of copies. So you'd either have to use the ref keyword or something like that to make sure that you're still passing that by reference, or do the work on the flyweight like the book was saying.
It's not strictly flyweight, but a lot of the dungeon stuff, we were working with all these like small objects because we didn't want to carry around a game object and all the rigid bodies and physics as we're just throwing stuff around the room. And so what we ended up doing was we have a lot of these like just fake objects which just care about a coordinate and something else. And so we did all our logic with that. And instead of having to carry it around. So it's a similar concept of splitting apart your data, but it works very differently since we could like tie to a common thing.
Good. So we happen to be going through these patterns alphabetically, and adapter and bridge very rarely come up as something to utilize. But for some reason this week, the Fs with Façade and Flyweight are things that you will probably encounter and use in the coming week or so. It's like it comes up pretty frequently. So these are frequently used ones. You put a little star beside these ones.
Just bookmark them on the web browser.
There you go.
It's interesting you say that, because that's how I felt. Like I felt like, oh, these really make sense, and I've had this problem to solve before. Whereas like adapter and bridge, I'm like, well, I can see how that's a problem. I don't think I've encountered that yet. You know,
Right.
like that was, yeah.
Okay. Any other thoughts?
I almost tried to use a decorator today and then talked myself out of it. So, I keep on trying.
Okay. Okay, then we'll wrap up here.
Cool.
Everybody. See ya.
Bye.